morning everyone. Today we are going to see operating system unit 3 session 4. In the previous session we have studied the concept producer consumer problem and algorithm based on that and race condition. So in today's session also we are going to continue with the race condition and how to solve this problem we are going to see. So we are going to understand race condition with an example. So in the previous session, we have seen one example on race condition, that is by taking the variable x, which is shared among two processes A and B. And if they don't synchronize properly, how the result has gone wrong. And if there is proper synchronization, then how the result will be correct. That we have seen. One more real example we'll see. So there is a ATM. In ATM, the operating system is implemented and that is linked with the bank. Now the John wants to withdraw some amount from his account and his balance in the account which is stored in the database is 5,000. Now he wants to withdraw some amount from the account. So he goes to the ATM. Now he wants to withdraw the amount. So first of all, what happens in the ATM machine? First, the balance will be read here. What is the current balance of the John? So it is the current balance will be read from the database, that is 5,000. Now if there is enough balance, then what happens? The balance minus withdrawn will be stored in the balance variable. So whatever is the balance, from that whatever the withdrawal amount is there, it will be deducted and the latest will be stored in this balance and later on it will get updated. It has to update. So updated amount will be stored in the database. Now at the same time there is another process, John's friend. Now the John's friends at the same time wants to transfer the amount to his account, to John's account. So now we are going to see here how two processes, that is John process and his friend process, if they simultaneously perform the task at the same time, what happens? If they synchronize and if they don't synchronize, how the problem arises and what happens, that we'll see. Wants to withdraw the amount 2,000. The balance in the John's account is 5,000. So before withdrawal, the balance will be read here. Yes, it is 5,000 and it is enough balance because he wants to withdraw the amount 2,000. So balance here is 5,000 and he wants to withdraw here amount, how much? 2,000. So the 2,000 will get deducted from the balance 5,000 and in the balance variable 3,000 amount will be stored. And now it has to update the balance. But before updating the balance, the another process has interrupted in between. Mac process, John's friend process, Mac, has interrupted in between and read the value of John's balance. It is 5,000. So the John's friend process, Mac, has read the value balance, that is 5,000. So whatever deduction of balance has happened, it's only present on client machine and still not updated on database server. So whatever this deduction has happened, 3,000 and all, it is still available on client machine and still it has to update on database server. But before updating on database server, the Mac process has interrupted and read the value 5,000. Here this side what happens, the Mac process is going to read the John's balance. If enough balance in Mac, then the amount will get deducted from the Mac's account. So the Mac wants to transfer the amount on the John's account. So if there is enough balance in the Mac's account, the amount will get deducted and will be transferred to the John's account. So John's balance plus the transfer amount. So John's balance it has rate is 5,000 and the amount which he wants to transfer is 4,000. So 5,000 plus 4,000, it is going to be 9,000. So 9,000 will be stored in this John's balance. See, it has read the balance 5,000 and but before updating it on the database server, it has read the wrong balance, that is 5,000, and due to which now the balance of John's, it is showing 9,000. It is showing 9,000. Now what happens after this process, after these steps? Now this code will get execute, update balance, and it is going to update the balance. The balance it is going to update is 3,000. It is going to update the balance is 3,000. So this is the latest balance which has stored in the database server. And later on, then again, even at this side, the max process, it is going to update John's balance. And it is going to update how much? 9,000. So again, latest value it is showing 9,000 only. After executing this and after executing this, the values are changed now. See, the John has balance 5,000, he has withdrawn 2,000 and the balance should be 3,000. But in between the Mac process interrupted and it has, before updating on the database server, it has read the value 5,000 and after transferring 4,000, now it is showing 9,000. 9,000. So the final amount must be 7,000 actually. But because of not properly synchronized and interruption in between, before updating it on the server, the other process has interrupted and read the wrong value, because of which it has resulted in wrong value. So this can be solved using the critical section problem. So in a critical section problem, the code which is very important, where the variables are shared, that part of coding is locked and we call it as critical section part. So the process is, before entering into this critical section part, has to take the permissions. So the process which are already executing the critical section part, and if the other process tries to enter into the critical section part, then that process is not allowed because already one process is executing that part. So like this way, every process is, before entering into that critical section part, before executing it, they have to take the permissions. Then this problem can be solved. There is a race condition. So the balance variable here is shared among more than one processes, and because of that the processes tries to raise the condition and tries to grab the value of that, tries to share the value of that variable. So because of this not properly synchronized, this problem arises and it is showing the wrong balance in the database. So to avoid such type of problems, in the previous session we have seen the locking system. So that locking system is like a critical section. We call that part as a critical section. So this problem can be solved using critical section, that is by locking that code. So critical section problem. So this problem can be solved using critical section by locking that particular important code, so that there must be no any interruption between other processes. Processes all competing to use some shared data. So each process has a code segment called critical section. So that code segment, which is very important, called critical section, in which the shared data is accessed. So that part is shared among multiple processes. So we call it as very critical section, which has to be secured from the interruption from other processes. Problem: ensure that when one process is executing in its critical section, no other process is allowed to execute in its critical section. So how this problem can be solved? When one of the processes is executing that critical section of the code, no other process should interrupt in between. Each process must ask permission to enter the critical section in entry section. May follow critical section with exit section and then remainder section. So whenever one particular process is executing in the critical section, and if other process comes to access that same part of coding, so before accessing that coding, the permission must be asked by the process, whether that process can enter into that critical section and execute. If there is other process already there in that critical section, the permission will be not given to that process. If there is no other process in that critical section, the permission can be given to that process to execute. So the permission will be asked in the entry section of the critical section. Before entering into the critical section, the permission will be asked, and then it will be exited from the critical section so that other process can enter. So when the process is entering and when it is exiting, this must be notified to the other processes so that other process can use that critical section and execute. So this is the format of the critical section. So how to write the critical section? So this is the loop. This is the entry section where the permission will be asked by the processes whether they can enter into the critical section and execute. And this critical section, the code which is very important, which is shared by multiple processes. And then exit section. So before exiting also they have to notify to the other processes that they are exiting and they have finished. And remainder section is they can execute the other remaining part of the section. So the processes may share some common variables to synchronize their actions. So to synchronize, some common variable has to be shared. So what happens with this solution with critical section? So how this solution will be helpful in synchronizing the more than one processes? So first one is mutual exclusion. So these are very important conditions which has to be made by every algorithms which are designed to solve these problems. So the various algorithms are written to solve these problems. So in every algorithm this has to be implemented. So first it should solve the mutual exclusion problem. So if process is executing in its critical section, no other process can be executing in their critical section. So that we call it as mutual exclusion. So what is a mutual exclusion? When one process is already there in the critical section which is executing, no other process is allowed to enter into the critical section until that process finishes its full execution and comes out and exits. Then only the other processes are allowed to enter. So this is mutual exclusion progress. So progress is if no process is executing in its critical section and there exists some processes that wish to enter their critical section, then the selection of the processes that will enter the critical section next cannot be postponed indefinitely. So progress means if any other process is not interested in entering the critical section, then what is the use of giving the chance to that process? So process should have the power or authority to enter in critical section if other processes are not interested. So if other processes are not interested to enter into the critical section to execute, then that processes must be not forced to enter into the critical section. The chance must be given to other processes who really needs to enter into the critical section and execute that part. So only the processes which are interested to enter into the critical section and execute, only those processes should be given the chance. That is the progress. Next is bounded waiting. A bound must exist on the number of times that other processes are allowed to enter their critical sections after a process has made a request to enter its critical section and before that request is granted. So this means when the processes are waiting to enter into the critical section, then that processes must be not allowed to enter for a long time. So after one round, two round waiting time, that process must be allowed to enter into the critical section. So when the algorithms are written, then such processes get stuck into the loops. In the loops they will be waiting. So more number of rounds, more number of long time, such processes must be not allowed to wait. They must be given the chance to enter into the critical section. So the critical section solves these all problems. So whenever the algorithms are implemented, these all three conditions has to be taken care into mind, that it should meet mutual exclusion problem, it should meet the progress and bounded waiting. So when these all are implemented in that algorithm, then it can solve the problem of synchronization. So in the next session, we'll see the various algorithm based on this critical section problem. Thank you.